Hello everyone. Our today's topic will be electrolytes. This is a very interesting topic. We have completed foods before it, and now we are starting with electrolytes. The first electrolytes which we are going to read is sodium. Okay, as you all know, this is the principal cation. Okay, so sodium is the principal cation of plasma and interstitial fluid, and its value ranges from 135 to 145 milliequivalents per liter. Okay, and as you all know, this cation is regulated by two hormones, which is aldosterone and ADH. So these two hormones regulate the level of sodium in the plasma. Usually, sodium and water move together. So, the infusions of sodium-containing fluid equilibrate between the vascular and the interstitial compartment. Okay. Now, what is the daily requirement of sodium? Daily requirement of sodium is yes. Daily requirement of sodium is 1 to 2 milliequivalent per kg per day. Okay. So 1 to 2 milliequivalent per kg per day. Suppose a man is weighing 50 kg, what will be his daily requirement? 50 to 100 milliequivalent per day. Suppose he is 60 kg, then 60 to 100 milliequivalent per day. Okay, but the requirement increases. This requirement increases if patient has abnormal losses, then requirement increases. अभी abnormal losses कैसे हो सकते हैं? Abnormal losses in the form of either GI fistulas, nasogastric aspiration, recurrent vomiting, diarrhea, bladder and bowel losses. Okay, so these type of losses increase the requirement of sodium. So we have to calculate what is the deficit and how to replace these losses. Usual requirement is 60 to 100. In 60 kg man, it is 60 to 120 milliequivalent per day. Okay, so this is the usual requirement, but it will increase if there are abnormal losses. So this is the one thing that you should remember. And one more thing which I would like to draw your attention to is what is the composition of various body fluids. Composition of various body. Okay. So first is the gastric juice. Suppose we have suppose here we have a sodium, potassium, chloride, bicarbonate. So, bicarbonate. So in case of gastric juice, what is the amount of sodium that we have? It is about 100 milliequivalent. These all values are in milliequivalent. Okay. In stomach, or gastric juice, 100 milliequivalent of sodium, 10 milliequivalent of potassium, 140 milliequivalents of chloride, and only gastric juice is there in which hydrogen is present, 50 milliequivalent of hydrogen. And approximate volume it is about 500 ml to 1 liter. So if you have recurrent vomiting or gastric juice nasogastric aspiration, and you have to give these supplements also. Okay. Second thing is the biliary juice. Why? You have 140 milliequivalent of sodium, 5 milliequivalent of potassium, which is equal to plasma, 100 milliequivalent of chloride, 60 milliequivalent of bicarbonate, there is no hydrogen, and approximately 500 ml to 1 liter of bile per day is secreted. Third is the pancreatic juice. Okay. So pancreatic juice also has 140 milliequivalent of sodium, 5 milliequivalent of potassium, 75 milliequivalent of chloride, and approximately 100 milliequivalent of bicarbonate. And approximate volume is 1 liter secreted per day. Okay. Next you have the intestinal versus duodenal secretions. It is also similar, 140 milliequivalent of sodium, 5 milliequivalent of potassium, approximately 80 milliequivalent of chloride, and the bicarbonate and hydrogen are absent as you all know. And approximate volume which is secreted per day is approximately 500 ml to 2 liters. Okay, so this is the secretion of the intestine. Then you have ileal secretions, additional ileal, and the colonic secretions. Okay, so the ileal secretion is 140 milliequivalent of sodium, 5 milliequivalent of potassium, 70 milliequivalent of chloride, and bicarbonate secretion. This is also approximately 500 ml to 2 liters of. Okay. And the colonic secretion, though they are less in amount, but still 60 milliequivalent of sodium, 70 milliequivalent of potassium, 15 milliequivalent of chloride, and approximately 30 milliequivalent of bicarbonate. So you have all seen that colonic secretions are very rich in potassium. Okay. So whenever there is colonic fistulas or whenever there is colonic loss or polyps or any colonic intestinal disease, then you have hypovolemia in such diseases. Okay, this you must note down, take a screenshot of this, and we'll all discuss about this, how to replace these losses in the future lectures. Okay, now how to calculate the deficit. Okay. So you have seen this one thing that most bowel losses have sodium losses similar to plasma. So they should be replaced with similar volume of sodium containing food. So if there is, suppose if there is 500 ml of ileal losses, it should be replaced with 500 ml of finger lactate or isotonic saline. Okay, so this is the most important thing that you should note because of diagrams. And now we will calculate the sodium deficit. So, how to calculate the sodium deficit? The formula is 0.6% into weight in kg into desired sodium minus the measured sodium. Okay, these two values are in milliequivalent per liter. This is also in milliequivalent per liter. Suppose there is a 50 kg man, okay, and his sodium value is 120. Okay, then what is the desired? Suppose it is normal sodium level is 135. You all know normal sodium level in plasma blood is 135 to 145. Okay, milliequivalent per liter. Okay, so suppose we take for ease of convention or for ease of doing this mathematics, we can take this as 130. Okay, 130 minus 120 is 10. 10 milliequivalent per liter. Okay, and what is the weight? Suppose is a zero point 0.6 into 50 kg man, 0.6 30. 300 milliequivalent. So this is the deficit of sodium that you must replace. Okay, so 300 milliequivalent of deficit that you must replace. Okay, so what is the total as you how has zero point 0.6 come? Because about 60% of the body weight is water, so zero point 0.6 from that only. Zero point 0.6 into the weight in kg, zero point 0.6 into 50 is 30. So this person, this 50 kg man will have approximately 30 liters of water in his body. Okay, so what is the desired rate of increase of body sodium will be, and one thing is that you should not infuse more than 0.5 milliequivalent per hour. Okay, sodium should not be given more than 0.5 milliequivalent per hour. Rate of infusion. So suppose desired rate of infusion of body sodium, what is the desired rate? How will you calculate? So it will be 0.5 into 30, which comes to be 15 milliequivalent per hour. This is the desired rate of increase of sodium. Okay. What is the fluid that one should use? Will be either NaCl 0.9% NaCl or 3% hypertonic saline. Okay, but the rate of infusion will be different. So what will be the time taken to correct this sodium? 300 ml deficit divided by 15 into the 20 hours. It will take approximately 20 hours. So you will give 100 ml of sodium chloride for 20 hours and 32 ml of hypertonic saline for 20 hours. Sorry, yes, for 20 hours. Okay. A lot of people have confusion regarding this percentage, milliequivalents, milligrams. So I would like to clear your confusion regarding this. Suppose there is a solution. We take, for example, we take 0.9% NaCl. Okay. So how to convert it into milliequivalents or how to know how many milliequivalents, how many milliequivalents of sodium it contains. Okay. There are few facts that must notice. 1 gram of NaCl or 1 gram of any salts. It could be either NaCl, it could be either KCl, sodium bicarbonate, calcium gluconate, calcium chloride, or magnesium sulfate. Okay. So 1 gram of salt contains how many milliequivalents of cation and anion. So these are facts that you should learn. Okay, so one it comes according to the either atomic number of the salt. 1 gram of NaCl has 17.1, or you can approximately take it to 17 millilent of sodium and 17.1 milliequivalent of chloride. Potassium chloride, it has 13 milliequivalent of potassium and okay, 13 milliequivalent of potassium and chloride. Sodium bicarbonate, it has 12 1 gram of 1 gram. This is 1 gram of salt. 12 milliequivalent of sodium and 12 milliequivalent of bicarbonate. So if you are given 12 milliequivalent soda bicarb, 1 gram, 12 milliequivalent of sodium and 12 milliequivalent of bicarbonate. Calcium gluconate, 1 gram of calcium gluconate has 4 milligram of calcium. Okay, similarly, 1 gram of calcium chloride has 14 grams of calcium and 1 gram of magnesium sulfate, 8 milligram of magnesium and equal amount of sulfate. Okay. So, these are the things that you should remember. So, suppose there is a fluid which is 0.9% NaCl. So, how you will convert 0.9% of NaCl? What you do, there is an easy trick. Multiply this 0.9 by 10. Okay, so 9. And write here milligram per ml. 9 milligram per ml. So this 0.9% NaCl means for every 1 ml you will have 9 milligram of sodium and 9 milligram of chloride. Okay. So if 1 ml has 9 milligram of sodium, okay, for example, we take only one cation and we are measuring, we leave the anion chloride and we have 1 ml of 0.9% solution. 0.9% NaCl solution will have 1 ml will have 9 milligram of sodium. So 1 liter will have 9,000 milligram of sodium. Okay, yes, you can write 1 liter will have 9 grams of sodium. Okay, so or 17.1 or 17 into 9, so 17.1 into 9 will be equal to 153.9 or 154 milliequivalent of sodium and also 154 milliequivalent of okay. This is an easy way you can remember. Next, so if you have 15% KCl and an ampule of about 10 ml, and you will have 150 milligrams per ml. Okay, 150 milligrams per ml, and then you will have 150 into 10, 1500 milligrams in 10 ml ampule. Okay, so this will come to 1.5 grams in 10 ml ampule of 15% KCl. Okay, if 1 gram of KCl has 13 milliequivalent of potassium, we have already read 13 milliequivalent potassium. Then 1.5 gram will have approximately 20 milliequivalent. Okay, so 1 ampule which is approximately 10 ml of potassium, 15% potassium chloride will have 20 milligrams. So if you give 1 ampule to a the patient will get 20 milliequivalent of potassium chloride. And what is the normal daily requirement? It is about 60 to 80 milliequivalent per day of potassium. So you have to replace it with 2-3 ampules of potassium chloride, which is 15% of KCl. With 2-3 ampules you can give over a period of 1 day. Okay. Similarly, 7.5% of sodium bicarbonate, which comes in 25 ml ampule, how much you can give? You can give according to the deficit of the bicarbonate and sodium. Okay. 1 gram of sodium bicarbonate has 12 milliequivalent of sodium and 12 milliequivalent of bicarbonate. So 25 ml ampule will have 1.8 grams, and then you can replace it with, that means it has 20